How is it going, everybody? In this video, I'm going to demonstrate how to perform a set of show commands on one or more devices. I did a similar video sometime back using secure CRT Python API, and this time around I'm using Netmiko module to basically do the same thing. And I feel that using Netmiko will be better in this case, and why? As one of the coding best practices is code reuse, and you ask yourself, why spend time writing the same thing when it has already been implemented and documented properly? And so in the next part of the video, I will add an enhancement to this script. I will show you how to use a Python cryptography package to encrypt password so that you do not expose your password in clear text in your script. And basically this video will have three parts: the basic script itself. Second part, we'll talk about encrypt and decrypting password. And the third part will be focusing on the enhanced version of the script, which is with the password encryption. Let's also have a look at the lab setup. Here I have three Cisco devices: router 1, router 2, and switch 1. And we'll run a list of commands through these three devices. And let's look at the script itself. Highlights of this basic script: there is no need to manually capture the output like in secure CRT. The output will be captured and written to a file, which here. And as well, if you look at the command list, right, there is no need to add terminal length 0 because Netmiko execute this command by default. It's worth mentioning that the heart of this script is actually the connect handler method itself, which is essentially the SSH instance. All this info you provide it, right, like the IP, username, password, these are all wrapped in a Python dictionary, and the connection info is actually sent to this connect handler object. So this SSH sessions instance, right, will log into the device and perform the task. Some of the prerequisite is, of course, to before using this is to do a pip install for Netmiko. And over here you need to specify your device list, and over here is the list of commands that you would like to run. I wrote this in Juniper, but obviously you can copy this script and paste it as a py file and run in any Python IDE. Let's run this script right now. I will name this as before. So this Juniper cell is now running with the asterisk. So after completion, it will also tell you the time it took to run this script. So it's done. Let's do a quick look at this file. And we did have three devices, right? So this is device 1, router 1, device 2, router 2, and device 3, switch 1. Done. This is pretty much the basic script itself. In part 2 of this video, I'd like to talk about the password encryption feature, I'll be using Python Fernet, a form of symmetric encryption. Essentially an implementation of AES, which means that the key that we use to encrypt will be also used to decrypt. I'll just quickly run through the steps. Step 1, which is this part, we will need to generate the key. The key is actually used to get the cipher. So actually I already run this, but actually I can run it again. I need to import before I can run this. So you see that the number changed, meaning yes, ran. So step 1 is obtaining the key again. Now we go to step 2. Step 2, based on the earlier provided key, right, and also the password, objective of step 2 is to obtain an encrypted version of the password itself. So let's run this, and it's actually done. So we go on to step 3, and this is to decrypt the password by providing the key itself and the encrypted password. And here I have two functions, which is to read both the key and the encrypted password, and they are actually fed to this cipher decrypt method to obtain the actual password. So do note that the password is Cisco. Let's run step 3, and we get Cisco. Let's restart everything and run step 3 alone. And this is to prove an important point that once step 1 and step 2 is completed, you only need to run step 3 of the code to retrieve the actual password. I will close out Juniper totally. Let's run it again. So do note of the cell. Right now the number is blank, right? Let's run this. It should get Cisco, and it did. And again, just to repeat, this is because the key is already locally in your computer, as well as the encrypted password itself. So with the password portion out of the way, let's move on to the last part of the video and look at the enhanced script before running. This is the basic script itself, and actually at the bottom, this is the enhanced script. As mentioned before, this enhanced script adds the password encryption feature, and we only need to include step 3 of the password decryption portion, and that will be enough to decrypt the password. I have a function here that basically reads again the key and reads the encrypted password, and both are fed to this method to return the decrypted password itself. Let's run this script with the password encryption feature. You do it by using Shift Enter. Ask you for the file name. I'll name it as after. Check that it's running. It's taking some time. Okay, it's done. Let's check the files. Let's also do a quick compare. Here we have the first device, router 1, and you can actually see the time diff because of the show clock. We go to device number 2. Finally, device number 3. So it's a comparison of the before and the after. Lastly, it's worth mentioning that if need be, you can also choose to encrypt the username portion using the same method over here, and you can actually put the username here and do the same thing. Second point is that you might notice that if someone runs your script, right, your password is not exposed because he actually needs to access both the key and the encrypted password itself that is stored locally in your computer. And that's about it, folks. And as always, the scripts are available via GitHub. Do see the video's description for the link. I hope this information is useful, and I thank you all for watching.